Here's the finished cube that you'll be able to build with the PiMios LED Cube Kit. Here's a rundown of the kit components. You have the Arduino Micro, the PCB where you'll mount the components, a USB cable to connect to the computer, 2 strips of header so you'll actually be able to make a socket so the Arduino Micro will be removable, 4 NPN transistors, these create your path to ground, 3 little rubber feet which will help elevate the PCB up off the table so you don't scratch the table. You have 150 and 330 ohm resistors, some wire, and your LEDs. Before you get started on assembly, let's take a look at some features of the finished cube. I'm just going to pull on the micro here and show you that it pops free of that socket made out of headers. If you look closely at the LEDs, you can see that there's actually a bend in each LED so it goes around the LED below it. Here you can see each of the paths to ground. There are 4 of them because each layer shares one path to ground. So all 16 LEDs of the top layer are connected to ground through this one wire. Same is true for this layer, it's connected via this wire, this layer is connected here, and this layer is connected here. We accomplish this by soldering together all of the shorter legs, the cathodes, of each layer. This spire of 4 LEDs climbing up the 4 layers is actually connected via the anode, the longer leg. They're all soldered together, so whenever there's current sent into the anode of this spire, wherever there is a path to ground, that LED will light up. You assemble the cube by creating each layer separately and then joining all 4 layers. So you're going to create first a layer of a 4x4 16 LED grid, and then you're going to make that 4 times, and then you're going to connect the top layer to the next layer, the next layer, the next layer, and then finally to the PCB. When building an LED cube, it's never a bad idea to test all your LEDs before soldering them together. You can do this with a battery, but here I've set one up so I can test them quickly using an Arduino Micro. What I've done is I've set this up so that the first header pin here is in row 1. Row 2 is where our 3.3 volt is, and that's in row 2. And that I have connected over here to the positive rail. This line coming off the negative rail, actually I have heading into ground, which is in row 14, provided that you started this so that the top of the headers goes in row 1. I can now press one of my LEDs into the rails here and test, see that it lights up. The convenient thing about doing it this way is that I can put as many LEDs into these rails as I can fit and test a lot of them at once. If you don't have a breadboard to test your LEDs, you can get away with using a coin cell battery. Coin cell batteries have just enough internal resistance so they won't blow out your LED. However, this is a sloppy solution. Connect the longer leg to the side with the positive, and you can test your LEDs. Here's the template I'll be using to shape the LEDs of each layer. You can download the source file and make your own, or you can just take a piece of wood or other material and drill one out. If you go to drill one of these out for yourself, the spacing between the holes is 7/10 of an inch in a square grid. By using 7/10 spacing, you can actually mount the LED cube on a breadboard in the event that you don't have the PiMios PCB. The breadboard spacing between the center of each of these sets of 5-dot rows is exactly 7/10. Before you begin soldering, you're going to need to prepare your LEDs by bending the legs. You're going to want to bend 16 of your LEDs the way that you see here on the left and 48 of them the way you see here on the right. This bend is in the anode, the longer leg. I'm going to show you how to do that. If you have the PiMios template, bending your LEDs is very simple to do. Take your LED and lay it in the slot here so the longer leg, the anode, is facing down and the cathode, the shorter leg, is facing up. Holding it in that slot, you just push down the anode to put a 90-degree bend inside of it. So as you can see here, I have a 90-degree bend inside of the anode. Pick up the LED and now feed it through this hole here so the cathode, the shorter leg, is passing through that hole and the anode is now sticking out from the template. I'm now going to bend that anode back down, put in another 90-degree bend in the LED leg. And there's the finished LED. Some users may feel that 2 bends in the lead is all you need. So as you can see, with 2 bends, you can safely pass around the LED of the lower layer. So when you solder these together, you can in fact make this connection. However, I like to put a little 45-degree bend back towards the center, so I actually give myself a little bit of a cross as I make these layers, so I have an easier joint to solder. To put that third bend in the LED, I just take a set of needlenose pliers, grip it on the end just a tiny bit. I don't want too much, just a tiny bit. Turn 45 degrees. And that's all there is to it. In the event that you don't have the template, you can still bend your LEDs using a set of needlenose pliers. The trick is to bend against the needlenose pliers, not use the pliers to make the bend. So try to get between the 2 leads and get a grip on that anode, that's the longer leg. Once you have a nice firm grip, Go ahead and bend that 90-degree bend of the anode, the longer leg, just by pulling it against the body of the needlenose pliers. Let go and grip it after the bend, and do the same now to bend it back in the original direction. And just like that, I have just about the same bend as the template. So why do only 48 of the LEDs need that 45-degree bend? Well, 16 of these LEDs are going to pass through the PCB. So 16 of them do not need that 45-degree bend at the end, and if you put it there, you'll actually have a very difficult time getting it through the PCB. Once you're finished bending your LEDs, follow up with me in the next video to begin soldering.